want to get the midpoint out of the way. I'm adding these two, and I get 3, and divide by 2. I'm adding these two, and I get -2, divided by 2, -1. So the average of x's, when I add 7 to -4, I get 3 divided by 2. And when I add 3 to -5, I get -2 divided by 2 is -1. And the distance, write the formula first. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. I recommend this method. It's not the only one. It's not the best. You choose. But I label them as x1, x sub 1, x, y sub 1, x sub 2, y sub 2. And then I have 7. I copy it underneath. And then -4. And then I copy -5. And then I copy 3. And I perform the calculations without using nested parentheses because that messes me up, but it's up to you. Minus minus is positive. So 7 plus 4 is 11. The square root, 11 squared. I know it's 121, but let's take it slowly. -5 minus 3. This is -8. -8 squared, I know it's positive 64. Please be careful. These two numbers must be positive because they come from something squared. Do not ever attempt to write a negative number there. So then I know that this is 121 plus 64. So this is the square root of 185. I may be asked to approximate, then I'll put in the graphing calculator. I may be asked to simplify. I don't know if we can simplify. So 5, and when I divide by 5, I get 3 and 7. Nope, we cannot simplify. So the approximation, that's the square root. So the square root of 185, and I got 13.6 if that's what we're asked. I don't know how many decimal digits. We have to check. I think that's what it was. I was talking. Yeah, I see. Sorry, don't write that. 13.60. How I came up with that, nobody knows. I don't know. Sorry about that. Okay. Anything else from the list?
Professor?
Yes, I'm ready.
On the test, could you put decimals down? I don't think you can, right?
Depending on what the question is asking you to write. If it says simplify and leave it exact, then you have to leave it as the square root of 185. If it says approximate, then you have to come up with that. Was that the question, Aaron?
Yeah.
Okay. Good. Anything else? We had tons of examples last time of quadratic, polynomial, and rational. Do you want to go back to that? We already graphed the rational function. That was done a few minutes ago. We already looked at the quadratic function, but we didn't graph it. We answered questions about the vertex, but we didn't graph the quadratic, so we can go back to that. We did not graph polynomial, to review. I don't think there is any need here, but we looked at domain of these functions, but we can go back and look at that. And inequalities. So these are the last topics that we haven't looked at yet.
Could you go over division? The synthetic division?
Yeah.
Stuff like that?
Yeah. So I'm not going to ask you to do the synthetic division, but you can use it. So for anything like, let's say, 4x to the third minus x squared plus 3 divided by x plus 2, the number in the box will be -2. And you have to be very careful with the coefficients because 4 is there for x cubed. -1 is there for x squared, but there is no x. So that coefficient has to be replaced by 0. So we have 4, we have -1, we have 0, and we have 3. One other indication of the answer, degree 3 divided by degree 1 will be degree 2. So the quotient will have degree 2. Okay, we always copy the leading coefficient. We always copy, we don't do anything to it. Now we continue with -2 times 4, which is -8. We perform the operations we see. -1 minus 8 is -9. Then -2 times -9, we write it above the line, which is 18. We perform the operations we see. And -2 times 18 is -32, which makes this a -29. I box it in because it's the remainder. So when I write the final answer for this, I will write that 4x cubed minus x squared plus 3 divided by x plus 2 has quotient, degree 2, careful, 4x squared minus 9x plus 18. The remainder is negative, that's why I copy negative, 29 over the divisor. Now, the remainder of this division must be -29. Can I check? Of course I can. In the top function, I plug in -1 in the top polynomial. So the polynomial of not -1, -2. When I plug in -2, I have 4 times -2 to the third minus -2 squared and plus 3. This number must be -29. If it isn't, then I have to go back to the drawing board and recalculate everything. So 4 parentheses -2 to the power 3. And then minus, in parentheses, -2 squared and plus 3. If the answer, when I click enter, if I don't get -29, I'll say, oops, I didn't. So what did I do? I did something. So let me check. Minus -2 squared. Okay, I have to go back to my calculations. So 4 was negative.
Wait, before you do anything, Professor, can you tell me how did you get the 4, -1, 0, and 3?
These are the coefficients of the polynomial in descending order.
What about the 0?
I was just saying that there is no term with x.
All right, then what about the 3?
There is a term with without a variable.
I thought you just said you give a term without a variable 0.
But this is the coefficient of the free term. So this is degree 3, this is degree 2, this is degree 1, and this is degree 0. Not power 0. Degree 0. All of them have to be in the table. Is that clear?
I mean, not really, but it's all right.
All coefficients of this polynomial. So the polynomial in general is like this: a x to the third plus bx plus c plus d. All coefficients, even if they are 0, have to be in the synthetic division. They have to be mentioned. This number has to be mentioned, this number has to be mentioned, this number has to be mentioned, and this number has to be mentioned. All 4. For degree 3, all 4 have to be in the syntax, in the algorithm. If they're missing, I have to write 3. But if they exist, I have to copy what they are. So this one is 4, this one is -1, the middle one, the term for 0 for x is not there, so I have to replace it by 0, and the free term is there. All these.
I got it.
Good. So now I have to find my mistake now. I can move on. So this is -8, that's correct. This is -9. This is correct. This is 18. This is 18. Ah! I got my error. -2 times 18 is not -32. Not today. But it's -36. -2 times 18 is -36. That's why -36 plus 3 is -33. Wake up, Monica. And this is indeed -33. And this is indeed -33. And this is indeed -33. My apologies.
So
Yes.
synthetic division is optional, right? Like we don't.
It only has limited applicability. I will not ask you to use it. It's very convenient, much faster when it's applicable. It's much faster than the long division.
Right.
But you don't have to use it. Even in this case, you can use long division.
Okay.
It's a good method to know, but it's not. I'm not going to force you to use it.
I personally like doing things the longer way.
That's fine.
Just because it's.
You have more control over it.
Yeah. Answer.
Yeah, I fully understand. Whatever works, I'm happy with it. Whatever. Every brain is different, so I'm happy if something works for you. Okay, anything else from the list? Maybe graphing a quadratic, graphing a polynomial. Are we okay with those inequalities with the table? I think that this is quite visual, but tell me what you need.
We go over the graphing polynomials.
Yes. Any degree? Any degree?
I know how to tell like end behavior, but sometimes it confuses me.
Very good. Any degree? You want an odd degree or an even degree?
Let's do an odd degree.
Good. What degree would you prefer? Would you prefer 3 or 5?
Degree 5.
Okay. Good. In order to make it a little bit easier, I'm going to present it in a factored form already. So, I'm going to make the second one negative inside. Is this degree 5, first of all?
Yes.
Yes. 3 here, x to the third, and 2 here, x squared. X to the third times x to the second power is degree 5. Perfect. I get the table going. There is no restriction here. It's not a rational function. Everything goes. Everything. So 0. I have to be careful with f of 0. 0 minus 2 is negative 2. Negative 2 to the third times 0 minus 3 is negative 3. Negative 3 squared. This becomes negative 8, but this is 9. So the answer is negative 72. Keep an eye on my numbers today, because as you saw, negative 2 times 18 was negative 32. Gee, I multiplied, in my mind was 16 instead of 18. My apologies again for that. Okay, so now when y is 0, negative x minus 2 to the third times x minus 3 squared, 0, I have to have 5 solutions. So degree 5, 5 x-intercepts, and also max possible number of turns is, by turns we mean max min, what is the maximum possible number of turns?
4.
Exactly, 1 less than the degree. Awesome. So please give me 5 solutions here and their multiplicities, because then we know what happens there. So 3 will be from here. Negative x minus 2 equals 0 means x equals negative 2. Multiplicity 3. The function will cross slowly. Negative 2, 0. Slow cross. And 2 are from here. X equals 3. Multiplicity 2. a turn. Degree 5 and a positive leading coefficient, or maybe negative leading coefficient. I have to be careful on that because it's a little bit hidden. So that's the last thing we need to talk about, and then we can graph it. So careful with this one because it's a little bit tricky. So f of x, there is nothing I can do to x minus 3 squared. This will always, you know, give a leading coefficient which is positive. However, for negative x minus 2 to the third, when I factor out negative 1 and still take it to the third power, just this piece, I'm talking about this piece only, to the third, then I have negative x plus 2 to the third. So the leading coefficient is negative. So if the leading coefficient on an odd degree is negative, the function must look like this, like the linear function with a negative leading coefficient. So it has to come from positive infinity and go to negative infinity. So infinity and negative infinity. And now we are ready to graph. Please do not ever graph asymptotes on a polynomial function, please. Okay, so the function is coming from positive infinity and slow crosses at negative 2. Slow cross. It's not like this. This is a fast cross. It's very slow. Maybe I should have showed that more here. Okay. Then it crosses at, I don't know where that is. So it's, I'm going to say 20, 40, 60, 80. So it's somewhere here. I don't know if it turns. Unlikely it will turn here. It may turn after. We'll see in a moment. But it has to come back to 3 and turn again. That I know. And go to negative infinity. I do not know for sure, but as I mentioned when we looked at these polynomial functions, when we graph a polynomial function, if I have to twist my wrist, then I know something is wrong. And this will be definitely a wrist twister. I can't do that. It won't be a function. So this is more likely. Very smooth curve. I don't think it turns here. I just made up that problem, so I have no idea. But it doesn't, it's almost impossible, I would say. I think this will be the smooth graph. And this will be the local minimum. This will be a local maximum. This will be just an x-intercept and nothing else. And this would be the y-intercept. So now we are ready. So this function is negative x minus 2 everything cubed and x plus, no, of course, it was x minus 3.
And on the test, if we have a problem like this, do we need to say whether it's symmetrical or not?
Very good question, yes. We have to write it for all these functions. I'm going to list so you don't forget. But obviously, if a function crosses at negative 2 and turns at 3, there is no way it will be symmetric with respect to the y-axis or with respect to the origin. But I have to write not symmetric. You can write that f of negative x obviously will never equal this for even and will never equal this for odd, for sure.